In this video we are going to talk about dividing polynomials, remainder and factor theorems. We know how to multiply two polynomials using the FOIL method. So in this video we are going to look at how to divide one polynomial by another polynomial. This will be much easier to understand by looking at an example first rather than studying the procedure. So divide x squared plus 5x plus 3 by x plus 2. So it's kind of like long division of numbers, long division of integer numbers actually. So you write what you need to divide inside this and what you need to divide it by here, like this. So it's kind of like dividing numbers. So first you take this term with the highest power, and here also you take the term with the highest power, and then you divide this by this. So when you divide x squared by x, you get x. So you put it here. Okay, you put it here. Then you multiply this by this. So when you do that, you have to use the FOIL method. So you will get x squared plus 2x, and you write it down this in this way. Okay, and then you subtract this from this from these two terms. Okay, so when you subtract, it's like this. So you have to subtract this from this. So this negative will get distributed, both of these will get multiplied by -1, and then you have to simplify. This will cancel, you get 3x. Okay, so actually this will cancel, subtract 2x from 5x, you get 3x. Then you bring this down. So it's kind of like dividing numbers. So now you have 3x plus 3. Then again you do the same thing. You divide this 3x by x, then you get 3. Okay, then you write it here. Then you again multiply x plus 2 by 3, by positive 3. Then you get 3x plus 6. Then you subtract, and when you subtract, you get -3, and -3 cannot be divided by x plus 2. So we stop here, and this result can be written as this divided by this equals this plus this thing divided by this. So in this way. Okay, so and when you multiply this by x plus 2, you get, so you have to multiply everything, so you get this. So -3 is the remainder. Okay, so when you divide this by x plus 2, you get x plus 3 and -3 as the remainder. So when we divide by a linear polynomial, the remainder will always be a constant. So the remainder will be at most a polynomial with degree 1 less than the divisor, than the degree of the divisor. Okay. Okay, so in this example, the dividend is this thing, the divisor is x plus 2, and the quotient is x plus 3, and the remainder is -3. Okay, so the divisor is of degree 1, so the remainder will be at most of degree 1 minus 1 would be 0, which is a constant. So polynomial with degree 0 means it's a constant polynomial. Okay, so if this is a quadratic divisor, then this can be, the remainder can be a linear function. Remainder can be can have x term. It can be something like 3x plus 1 or something like that. Okay, so if this was a cubic polynomial, and if this can be divided by that, then if this has enough power to be divided by a cubic polynomial, then the remainder will be a quadratic function, a quadratic polynomial. Okay, so example 2. So again you divide x squared by x, then you get x, write it, then multiply, you get x squared minus 3x, write it here, then subtract, this will cancel, this will become positive, then you get 5x plus 3x, it will be 8x, because when you subtract a negative quantity, it becomes positive. Okay, so this FOIL method and taking out factors and taking them in is very important in this course. Okay, and throughout mathematics. So you have 8x, and bring this, you have 8x plus 4, divide 8x by x, you get 8, write it here, you get 8x negative 24, subtract, this becomes positive, they add, this will cancel, you get 28 as the remainder. Okay, so again it's like this. So the divisor is linear, so the remainder is a constant. Okay, if the divisor was a quadratic function, the remainder can be a linear function, a linear polynomial. Okay, so this is the procedure written in a formal way. So arrange terms in the dividend and divisor in descending powers. Divide the first term of the dividend by the first term of the divisor. The result is the first term of the quotient. Multiply the divisor by the first term of the quotient. Remember to use FOIL. Write the resulting polynomial below the dividend with like terms aligned, and subtract it from the like terms of the dividend. Bring down the next term in the dividend and write it next to the remainder obtained in the previous step. Repeat the process by taking the expression obtained in the previous step as the dividend until it can be no longer be divided by the divisor. Okay, so this is the procedure written in a formal way. Okay, now we come to an important thing, which is called the division algorithm. So let f of x and d of x be polynomials with d of x not being identical to 0 and the degree of d of x being less than or equal to the degree of f of x, so that it can be divided. Okay, you cannot divide by a polynomial with higher degree. Okay, then there exists a unique polynomial. Then there exist unique polynomials q of x and r of x such that the following is true for all values of x. So this is the same thing what we had earlier written in general notations. Okay, so what we have here, what we had here, so this is what is being written here in a formal general way. Okay, so this is the dividend, you divide it by the divisor, then you get the quotient and the remainder. Okay, so it's the same thing written in like f, d, q and r, so general functions. So degree of the quotient is always degree of the dividend minus the degree of the divisor. The degree of the remainder is less than the degree of the divisor. Okay, so this is what we so I said this earlier. So the degree of the remainder is less than the degree of the divisor. Why is that? That is because we stop the process of dividing when we have something with less power than the divisor. Okay, so for example, in this example, we stop when we got 28. So this is a constant, so the degree of this, so if you consider this as a polynomial, the degree is 0. So here you have degree 1, so you cannot divide. So that's why the remainder is always so the degree of the remainder is always less than the degree of the divisor, because if not, we can continue the process. Okay, so if we have stopped it, that means we cannot divide, and what we have here has less degree than this. Okay, has less degree than the divisor. So the remainder must have less degree than the divisor. Okay, otherwise you can divide it further. Okay, so the degree of the remainder is always less than the degree of the divisor, otherwise you can divide it further. Okay, so example, when you divide a polynomial by x minus c, the remainder is a constant. Okay, so the constant is a polynomial of degree 0. Okay, so constant function means it can be taken as a polynomial of degree 0. So this has degree 1. When you divide by this, you get so the remainder would be a polynomial with degree 0. 1 minus 1 is 0. So polynomial with degree 0 means it's a constant. So it's a constant function. Okay, so if you divide it by quadratic polynomial, the remainder can be a linear polynomial. Okay, so that we discussed earlier. Okay, so if remainder is identical to 0, f of x factors into d of x and q of x. So if the remainder is 0, that means these are factors of f of x. Okay, so then the divisor factors f of x. Okay, and sometimes the quotient and the divisor may be further factorizable. Okay, now we come to an important theorem, which is called the remainder theorem. Okay, so when a polynomial f of x is divided by x minus a, the remainder is always f of a. Proof. So by division algorithm, when we divide by x minus a, we always get a constant. So let that constant be r. So this is independent of x. It's a constant. Because this is linear, it will be a constant. Okay, degree less than the divisor. Okay, the remainder must have a lesser degree than the divisor. Okay, so here the degree of the divisor is 1, so the degree of the remainder would be 0. 1 minus 1 is 0. Okay, so at most 0, so that means it's 0. So degree being 0 means it's a constant, because x to the 0th power is actually 1. Okay, so if this was a quadratic polynomial, we cannot write this. Then we have to write a general linear polynomial here, something like px plus q. So we have taken q here, so something like px plus r or something like that. Okay, so since this is linear, this is a constant. Okay, so constant means it's independent of x. So it's not something like r of x. It's just r. Okay, so since the divisor is of degree 1, the remainder is a constant and does not depend on x. Since a is true for all values of x, we can let x equals a in the equation a. Okay, so if you plug in x equals a, you are plugging it here, here as well as here, and r will be constant. Then you will get this equation, and this thing will be 0. 0 times this thing will be 0, so you get r equals fa, which proves the theorem. Okay, r equals f of a. So this proves the theorem. Okay, so this is a very important and interesting theorem. Okay, now we come to another theorem called the factor theorem. This is also a very important theorem. So this follows from the earlier theorem. So this says if f of a is 0, then x minus a is a factor of f of x. Okay, so f has to be a polynomial. If x minus a is a factor of f of x, then f of x this has to be actually f of a equals 0. Okay, this has to be it's not x, it has to be f of a equals 0. Okay, so it's the opposite of this. Okay, proof of part 1. In the previous theorem, we proved that when we divide a polynomial by x minus a, the remainder is f of a. Okay, so according to the division algorithm, it is this. When you divide by x minus a, remainder is f of a. Okay, and you have quotient which we don't know. So this can be a function of this can be a polynomial of degree. So it will be like, if the degree of f of x is n, degree of this would be n minus 1, because this has degree 1. So n minus 1 would be the degree of this polynomial. And since this linear, this is a constant. Okay, so this has no x terms, so you have actually substituted, you have replaced x with a in f. Okay, so since you have replaced x by a, there won't be any x terms here. So this does not have any x terms, so it's a constant. So although it has f, since we have substituted a for x, this is independent of x. Okay, so this is the division algorithm, and if f of a is 0, this means this would be equal to, so just x minus a times q of x, which means x minus a is a factor of f of x. Okay, so if f of a is 0, it's just this, so this will vanish if it's 0. Then that means x minus a is a factor of this, because this is a polynomial. Okay, which proves part 1. Then part 2, if x minus a is a factor of f of x, then f of x can be written in this way, where q of x is a polynomial of x. Okay, then when you plug in a for x, this thing will be 0. 0 times q of a would be again 0. So when this is 0, this whole thing would be 0, so you get f of a equals 0, which proves the part 2. Okay, so since b holds true for all values of x, we can let x equals a in b, which will give us f of a equals 0. Okay, this proves part 2. Okay, So let f of x equals 2x cubed plus 13x squared plus 17x minus 12. Evaluate f of minus 3 and solve the equation f of x equals 0. Okay, so this is a typical exam question in this course. So evaluate f of negative 3. So you substitute negative 3 for x. Okay. Then when you cube a negative number, you get a negative number. So it will be negative. And when you square a negative number, you get positive. And this is just multiplication. And you have negative 12. And you multiply these. Then you get these two. And you simplify, you get 0. So f of negative 3 is 0 means x minus parenthesis negative 3 will be a factor of f of x. So x minus minus 3 would be x plus 3. So x plus 3 would be a factor of f of x. Okay. So since f of negative 3 is 0 by factor theorem, x plus 3 is a factor of f of x. So since this 0, this is a factor, which means so this is equal to this. So that means x plus 3 is a factor. Okay. So f of negative 3 being 0 means x minus minus 3 is a factor of f of x. But this is equal to this, so this is a so this is a factor of f of x. Okay. So we can write so we can divide f of x by x plus 3 using long division or synthetic division if you want. So if you do that, the quotient will be this and the remainder will be 0. So that you can do it as an exercise. So you'll get, so when you divide by x plus 3, you get the quotient this and no remainder. And you can further factor this like this. So this quadratic polynomial can be factored like this. So you in fact have 3 factors. So you have 3 solutions for the equation f of x equals 0. So the solution set is this. Okay, that's it for this video.